Hello, welcome to this video. We'll be going through the USACO 2017 December contest, bronze problem 1, block billboard. You can go ahead and take a quick read through of this problem, and then we'll get started. Okay, so let's take a quick look to see what are the things that were given and the things that we need to find, and some insights that might help us. So one thing that we know, or the thing that we're given, is that we're given the coordinates x, y, or x1, y1, x2, y2. Those are the coordinates for the lower left, those first two numbers, and the upper right, those are the last two numbers of each billboard, and as well as the truck that is blocking. We're also given that, so the coordinates range from -1000 to 1000. And the two billboards have no intersection, so they don't overlap in any way. So you can think of those as two separate rectangles somewhere out in space. So what we're trying to find is the total area of the billboard that remains visible for both of the billboards. So a quick illustration might help. So let's say we're given this billboard. We'll call this number 1. And then we're given another billboard. Number 2. And then let's say we're given the truck right here. So a truck may block anyway. So maybe the truck blocks something like this. So everything that's still visible is this one and this one, not counting this one. So that would be one easy step there. It could also be the case that, say, the truck is like this. So it's blocking just part of it. So everything in here is fine for both of them. But then this sliver right here is the one that we need to take off. So one thing we can try for this is, first we can find the area of both the billboards. So that would be base times height, base being this side and height being here, for both of them. And we can also get the area of, or the intersecting area, so the area that's found in here, and subtract that from the total. So the basic solution should see something like this. So A1 is the area of billboard 1, and then we had area of billboard 2, and we know that maximum in the maximum case, yes. So if the billboard was not being blocked, that's how much visible space there would be. But we also need to subtract out the intersecting area. So intersecting between 1, we'll say 1 in the truck. So I1 is, we need to figure out the formula for that, but we need to subtract I1 and subtract I2, which is the intersection here. And this is I1. So let's just quickly think about how we would want to do the intersection place. So the way the intersection works is, so billboard 1 we know is probably somewhere to the left of the truck, or we can kind of think of that as left of the truck. In this case, then, I guess the box is bounded by, say, this lower left point and this upper left point. Let me actually change that. And same thing for this one. So it's bounded by this point and this point. So we're trying to find somewhere to actually determine what the value is. Right. So the base of that should either be so the length, or the bottom part in this case. That one is bounded by the x value here and up till there, and then the I guess x value here. I think it might be easier to see it in code because we're trying to find the value there. So in this case, we're trying to find the maximum either to the right or the minimum to the left. And then, or well, right and left. So the minimum for here is the left side. The minimum for the maximum of the right side is here. So, and then subtract the two and you get the base. And it's going to be the same thing for height. So the height is find the minimum bottom, so the lowest point that's still inside here. and then get the highest point that's still inside here. So that's here. And that will give you the height of the intersecting one. So there will be some kind of base, which we'll call, right now the base is unknown, and the height itself is unknown. We can actually see in the code that we'll just need to have a minimum, or in this case, h here should be the maximum right, max right minus minimum left. So try to find the farthest right value that's still in there. Try to find the smallest left value that's still in there, and that should give you the. Oh, sorry, that should give you the base, not the height. And something similar will be for the base, the height, where that's the maximum top and the minimum bottom for the height. Okay, so let's go ahead and see how the solution for this gets translated into Python code. So to keep track of how the rectangles work, the way I handle this is for x1, y1, x2, and y2, I enumerate them as just an index in a list. So x1 is 0, y1 is 1, so on and so forth. I also keep track of the rectangle. So what rectangle we are as well is in the list. So in this case, Billboard 1 is the first element, which is 0. Billboard 2 is the second element, and truck is the third element, which is number 2. That's based on just the way the file works here. And then what I do for that is, when reading in the file, I just create a list of rectangles. And then for like enumerating through the rectangles, get the value on the line and just make that into an integer. And then that should be the value from, the first value is x1, second value is y1. You keep doing that until you get for all rectangles. And then I just return the rectangles. So the solution is very similar from the one before, where the answer, let me expand that out. I think that's, so the answer I get is the area 1, so that's rectangle 1, or the Billboard 1. Area 2, which is the rectangle 1, which is Billboard 2. And then the intersecting area between rectangle 1, which is the Billboard 1, and the truck, which is rectangle 2. Same thing for Billboard 2 and truck. So this part is the adding part, and this part is subtracting out the parts that we no longer see. So let's quickly see how that works. So area, obviously from before, it's just base times height. So in this case, base is, I think it's this one. So 3 and 1, since those are the x values. So 3 is the right side. So that means that's the higher one, and 1 is the left side, so that's the lower one. And then this one, 2 is top, 0 is bottom. So top minus bottom is the base, or the height, and right minus left is the base. That gives the area. Simple enough there. Intersecting area is a little bit more involved. So same thing as before, we still have the base times height here, but to calculate what the x and y values are, the x value is defined as the minimum between the right side. So try to minimize the right side. Oh, sorry. I think from the illustration I had before, should actually be the opposite. So it's actually minimum of right and maximum of left. Right, sorry, I got those two mixed up. The reason why we want to have the maximum left and the minimum right is because we want it to be inside that square. So we want to have the highest value that's still inside the square, or the highest value on the left that's still inside, and the lowest value on the right that's still inside. Or just outside, actually. So on the boundary. So that's where this comes in. Maximum, same thing. From there, that's the left side. And then this one is top and bottom. So minimum top, maximum bottom. That gives you your y value. And in certain cases, it could be possible where X and Y, they may not be, or their intersection is actually outside. So for example, you could take the issue where maybe the truck, instead of being here, let's say I draw the truck in this brown color. So maybe the truck is something like this. You can see that none of the red is being touched, ignore this one. So that means the minimum value is actually here, and the maximum value is here. So that means it's going to be a negative number because there's no intersection. So we're just going to default that to 0. And after that, we return the base times height here. And then running that, you write the file and then just write the answer. And so if everything works out right, you should get 17 given the sample solution as the output. Mhm. Thank you for watching and have a nice day.